So good morning, everybody. Today is the third day and first session. So we are starting. Our resource person is already there. I can find it. Please give me 1 minute. So today we are having with us Dr. Navin Chandra. He is Associate Professor, Department of Statistics, Ramanujan School of Mathematical Sciences at Pondicherry University, Pondicherry, India. He is MSc and PhD Statistics from Banaras Hindu University, India. He is a recipient of Senior Research Fellow in a major research program sponsored by Department of Science and Technology, Government of India in the year 2000 to 2002. Dr. Chandra has got experience of 18 years, both in teaching and research. His area of interest in research is reliability theory, survival analysis, and Bayesian inferences. He has completed one major research project sponsored by UGC during 2013 to 2017. Under his supervision guidance, till now 3 numbers of PhD thesis has been completed. He has published many research papers in peer-reviewed and SCI index journals, conference proceeding books, book chapter, etc. He is the life member of more than dozens of professional bodies and societies in statistics. Dr. Chandra has participated in many seminars, conferences, workshops, webinars, etc., where he has delivered many invited talks and session chairs. He is the editor and editorial board member in 20 plus journals of repute. Apart from that, he is the member in various academic bodies across India. Today, his topic of deliberation will be non-parametric test analysis interpretation with example. Sir, I welcome to the Department of Business Administration, Assam University, and to this FDP.
Thank you.
Good morning. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you very much. Yeah. Shall I start?
Yes, sir. You can start.
Yeah. So good morning to one and all my dear participants. First of all, thank to the Devjyoti who has given me an opportunity to deliver a talk in this workshop and program. And today topic is my lecture is non-parametric test analysis interpretation with examples and exercises. So I'll be happy to deliver this lecture in this program, and I would like to now share my presentation here. Just a moment. Yeah, just a moment. So is it visible to all? Hello?
Yes, sir.
Yes, sir.
Yeah. So this is my title of the talk, and and this is the content of my presentation today. So I initially started introduction part, elements of parametric and non-parametric tests, data evaluation and its types, normality checking of the data set, essential concepts of hypothesis of testing in parametric and non-parametric tests, circumstances to use non-parametric tests, that is also important, advantages and disadvantages of non-parametric tests, and finally come to the main goal of today's presentation, non-parametric test for one sample test. In the one sample test, I have planning to discuss the sign test, Wilcoxon sign rank test, one sample run test for randomness, and some problems, associated working problems, and I will also provide some exercise for your practice. Followed by non-parametric two sample test. In the two sample test, pair sign test, Wilcoxon matched pair sign rank test, Mann-Whitney U test, and some working problems will be discussed in my lecture. And then I will provide finally some problems for the participants for their exercise. And then finally, last chapter of today's presentation, non-parametric case sample test will also be there. Kruskal-Wallis test, Friedman test, and associated working examples and problems will be provided. Finally, I will come to the demonstration of problem solving using SPSS, then questions and clarifications. So my aim is here to provide enough idea and knowledge in detail and on each of the topics what I had just read, and also some working problems. How do you have to implement the ideas in working problems, in real life problems, if you have a data? How do you apply? That's most important. If you understand, that's why I have taken some small examples here, working examples, so that you understand how these ideas are implemented. Then finally, I will have a demonstration for problem solving using SPSS. Then finally, we'll have a question queries. Now I am coming to the my business introduction. In this introduction, you might have aware about some basic concepts on probability, population and samples, random samples and data type of data. For better understanding the statistical concepts in attempting various problems, and finally productive solution with inferences. That is the main goal of the learning of subject concern. Okay, so in general, for any statistical investigations, we collect to draw a random sample from a target population, then using appropriate statistical tools like correlation, z-scores and t-test, etc., to describe the population and or make inferences about a population using random sample. That is the main important point. So a population must be defined properly. That's most important, because what you subject you are going to handle, for that subject concern, you must have a boundary of the population, because where all these units or individuals are existing. Okay, so we must have a complete clear-cut definition of the problem which we are handling. That's most important, because you have a goal to achieve the aim of the problem. Okay, and appropriate sampling technique also must be used for conduct the random sampling, because you are going to have a random sample, whatever study you are going to have based on the random sampling. Okay, so that's why a appropriate technique would also be used. Basically, the concept of testing of a statistical hypothesis play an important role in performing both parametric and non-parametric tests. Okay, so my goal is here to discuss the non-parametric ideas and methods, but I will give some differences between parametric, when do you use parametric, and why not use this parametric, why we go for non-parametric test. That's most important to get the answer. For that, I would like to discuss elementary ideas of parametric and non-parametric test here. So testing of a statistical hypothesis play a major role in statistical investigation. In this method, an investigator is concerned with examining the truth or otherwise the hypothesis, assumptions, or it may be claims or guesses, etc., about the feature of one or more of populations. Okay, so testing of hypothesis involving parameters such as mean, variance, or proportions. It is represented by Greek letters. So for example, I have tabulated here population parameters. These are called population parameters, representing by the corresponding Greek letters: mu, sigma square, and proportion p, rho, and sigma, standard deviation, regression parameter beta, and correlation rho. So the parameters representing the some unknown characteristics, I must tell you, real or hypothetical, of a population, which is ultimately to be estimated or tested. Okay, so our main goal is here to estimate the unknown characteristics of a population. These unknown characteristics are representing by a parameter, what we used to call parameter. That is the parameter. So a general statement of perception of hypothetical assumption about a population is to be verified or tested, true or false, by calculating the statistic by using a sample for rejecting the null hypothesis. That is the main purpose of the testing of hypothesis. So what is statistic? Also an important point. So a statistic is a function of sample observations and an estimator is a statistic. Okay, for example, sample means, sample medians, sample variance, sample correlation, etc. are these statistics. Whatever the functional form having all these samples, that is what the statistic we call. So a statistic gives a point value or point estimate of the population parameter. Okay, that is our concern. For example, there is you can have a height of all the participants. So what is an average height of the population we are interested? We must have to go for calculating the mean. So that mean involve all the sample value as a height. Then we can get these a point value, a single value, that is called the point value. Okay, so a t, a capital T, which I representing t is a function of x1, x2, xn. These are my sample. These are samples. So the statistic is a function of sample observation only. So those samples we are going to use to estimate the population parameter. So is a statistic we call or estimator. So parametric statistical procedure includes test, hypothesis. Okay, just a moment. Yeah. Uh, Parametric statistical procedure includes test hypothesis based on the student's t distribution, analysis of variance, correlation analysis, and regression analysis. Almost all the large and small sample tests, namely Z test, T test, chi-square test, and F test, are based on the assumption of parent population. Okay. A general statement or perception or hypothetical assumption about a population is to be verified are tested, true or false, by calculating the statistic, which already I told you. Okay, so here just a moment. From which the sample drawn has a specific form of distribution, such as normal distribution. For example, if a random variable describes a normal population, we say that population is normal, and where that is representing by capital N, mu, and sigma square. Mu is the population mean, and sigma square is the population variance. That is the ultimate our aim is to estimate the population parameter when we perform the parametric test. Okay, so a few parametric methods include the testing of a statistical hypothesis about the population mean under two different conditions, by assuming that sampling is from a normally distributed population with known variance and unknown variance. Yes, the non-parametric methods, however, are not based on the underlying assumption. Okay, and thus do not require a population distribution to be denoted by specific parameters. The analysis of data often begins by considering the appropriateness of the normal distribution as a model for describing the distribution of the population. If the distribution is reasonable, or if the normal approximation is deemed adequate, then the analysis will be carried out using normal theory methods. If the normal distribution is not appropriate, it is common to utilize a parametric test by applying the mathematical transformation to the sample values. For example, whatever the data set you have checked, the normality does not exist the case, you may have a way to make it in a usable, how to use and check the whether normality by taking the log of all the observation. That is what transformation form, that is what that now new observation is y is log x may yield that that are normally distributed. So the normal theory method may be applied to the transform data. So you can check, you can transform data. In addition, transformation do not always work. That is also important, I would like to mention here, such as when data sets have particularly long tails. Okay, since population do not always meet the assumption underlying parametric test, and validity do not depend on rigid assumptions. However, non-parametric statistical procedure fill this need in many instances, since they are valid under very general assumptions. Non-parametric tests do not require such assumption. A non-parametric test is a test that does not make any assumption regarding the form of the parent population from which the sample is drawn. Okay, So hence, non-parametric tests are also known as distribution-free tests. So, okay, and non-parametric tests utilize some simple aspects of sample data, such as sign or measurements, order relationships, or category frequencies, and rank formation. Therefore, stretching or compressing the scale does not alter them. Now, I must explain here data valuation and types. The data must be valued by the investigator. Whatever data you are aim to analyze the data. I have data I have. Most of the researchers used to come with the data, sir, I have data. I want to perform some appropriate statistical method. I want the findings. Okay. So before that, a data must be valued by the investigator and must be experienced in identifying the structure or nature of the data collected. A sincere attention is needed for scrutiny of the existing data. Okay, so not to suddenly start and working with the data. Data must be checked properly. In fact, you need to restudy about the primary or secondary data sets of its types. So I have question here. What is the form of data you have? Whether data is usable, whether statistical regularities are followed in creating or collecting a new data sets on a subject under study. These are the important questions to be answered by the investigators themselves and to study of the data is my suggestion. This is things to be cared by an analyst or investigator for statistical analysis and drawing the conclusion. So types of data, there are basically two types of data: discrete, continuous. So discrete data, there are types of that assume only exact value, and some examples are here: the number of train in a day, or number of flight in an hour, number of flower ready to pluck in the morning, the number of roses in each plant in a garden. Like this, these are some examples of the discrete example. And another is the continuous, and that continuous I will here. Yeah, unlike for discrete data, continuous data can take any numerical value. The length of a pencil, it can be some centimeter, and the mass of a fruit, and the time taken in finishing research work for or completing thesis. These are some examples I have here given to understand. Other type of data is also important to know. There are some other type of data: nominal, ordinal, interval, and ratio measurement scales. Now we discuss about some measurement scales. What is nominal data? Nominal data refer to data that it organized in terms of category or name. Some examples are the fat or thin characteristics of individuals, the color of people's hair, gender, religion. Nominal data, also called categorical data, are represented by counting the number of times a particular event or condition occurs. Okay, so this is what I have mentioned about the nominal data. And then ordinal data. What is ordinal data? uh, the ordinal data describe value that occur in some order of rank or ranking of item in some order. For example, very happy, happy, unhappy, very happy, strongly like, natural, dislike, strongly dislike. For example, the scale asks to respondent to make a judgment using a scale of 3 or 5 or 7 items. The range of such a scale might use 1 to represent strongly disagree, while 5 might represent strongly agree. So this is some example I have given here. Interval scale. An interval scale is a measure in which the relative distances between any two sequences value are the same. Interval data are also called integer, are types of data for which the measurement can be calculated and the difference in sizes can be compared. So for example, days, months, years, temperature in Fahrenheit, like this. So finally come to the ratio scale. A ratio scale is slightly different from an interval scale. Unlike an interval scale, a ratio scale has an absolute zero value. It can be multiplied and divided. Mass, length, distance, speed. In such cases, the zero value indicates the measurement limit or complete absence of the particular condition. Now, example, it would be appropriate to measure light intensity with ratio scale. Total darkness is complete absence in the light of light and would receive a value of 0. Now, second of the my uh, content is normality checking of the data set. That also important. Okay, so computing and testing Cartesian skewness for sample normality. So a frequency distribution that resembles a normal curve is approximately. So look at here, this is the normal curve, and here inflation point both sides. There's the point here, and mu that is what mu is mean, median, mode is there, and this is symmetrical curve. We call this is symmetrical curve, and however, not all frequency distribution have the appropriate shape of the normal curve. Okay, whatever data, all not all frequency distribution. Okay, the value might be densely concentrated in the center or substantially spread out. The sphere of curve may lack symmetry with many values concentrated on one side of the distribution. Okay, yeah, which we use in terms skewness and kurtosis to describe the conditions respectively. So we have to try to check the data condition, whether it's symmetric or asymmetric. So we have to see these are the some of the conditions: skewness and kurtosis, positive, zero, negative, and kurtosis, plateauchotic, and mesochotic and leptochotic. Kurtosis is a measure of sample or population that identifies how flat or peaked it is with respect to the normal distribution. Under another way, kurtosis referred to how concentrated the value are in the center of the distribution. And then I have here another graph. Skewness of a sample can be described as a measure of horizontal symmetry with respect to the normal distribution. And here you can see left skewed and right skewed, and mean, median, mode is also there in the picture. And if a distribution scores are concentrated on the right side of the curve, it is said to left skewed. A left skewed distribution has negative skewness, and if distribution scores are concentrated on the left side of the curve, it is said to right skewed. A right skewed distribution has a positive skewness. Okay, so the data what we have fitted and observed and checked whether it has normality or non-normality, this has to be checked with that. So if this the kurtosis and skewness can be used to determine if a sample approximately resembles a normal distribution, because you have a sample, you wish to check whether the sample is normality holds, then we can go parametric test. If it is not the normality condition holds of your sample you have, then you can prefer the non-parametric. Okay, there are 5 steps for examining sample normality in terms of kurtosis and skewness. It's very easy also. That's why it is very easy to work out. Determine the sample mean and standard deviation. Determine the sample kurtosis and skewness. Calculate the standard error and kurtosis and standard error of the skewness. Calculate the Z-score for the kurtosis and Z-score for the skewness, and compare Z-scores with the critical region obtained from the normal distribution. So these are the measures you have to obtain with your data set, what you have in your hand for checking the normality. So look at the standard normal distribution curve here, and these are the formulas we will use finally, skewness and kurtosis for the given data. So we have to find out skewness, SK, and we have to find out the K for the second column kurtosis, this value, and then standard error of the skewness and standard error of the kurtosis. Then finally we use the first formula given in the both the columns, skewness and kurtosis, and then we compare this Z value, and we observe that if Z value is lies in minus 1.96 to 1 plus 1.96, which confirms normality of the data set. And provided what you have taken taken alpha level of significance. Okay, the probability level where we reject the hypothesis. So you have taken 0.5, so means 95%. Okay, so for that the table value is minus 1.96, 1.96 plus. So in range, your the calculated value, the statistic z score value if lie, then it is a confirmation that your data is the normality. Okay, so this is the what I have could explain you. Now essential concept of hypothesis of testing. uh, when we demonstrate the parametric or non-parametric test procedure, we must adopt step by step hypothesis of testing procedure. We first define the test hypothesis concerned to the problem handling. So what I have here given statement of null and alternative hypothesis. First, we define the null hypothesis and alternative hypothesis. We first define the hypothesis for performing the test. The null hypothesis is a statement that indicates no difference exists between condition or group or variables. So what we define h naught mu1 is equal to mu2, and its alternative will be that is called the alternative hypothesis. But we have h1, there is a possibility mu1 may be greater than mu2, mu1 less than mu2, or mu1 is not equal to mu2. So when we take mu1 greater than mu2, that is what the right tail one sided, and left tail one sided, that is what mu1 less than mu2, and mu1 is not equal to mu2 taking means both sided, that is called two tail test. So these are the possible alternative is there, we have to check. Okay, this first we set the hypothesis of any problem which we are handling. Even you go parametric non-parametric test, hypothesis whether audible. Hello, hello.
Yes, sir.
Okay, okay. Then we fix the level of risk, and that is what the level of significance, that's important. So there is what the two types of error which I have also mentioned here. Where null hypothesis is true, we do not reject the hypothesis h naught, and no error, and that is what we accept, and we reject h naught type 1 error, and null hypothesis is false type 2 error when we do not reject the error h naught. And
Sorry to interrupt you, sir. Again, your voice is breaking, sir. Sir, if you are able to hear me,
my university's power has cut. Possibly will come soon. Not taking much time, but I expect that power will come soon. Then it will be everything will fine.
yes, sir. Now, sir, your skin is visible, sir.
Yeah, yeah, yeah. So yeah. So alpha we choose 0.05. Using that, there is 95% chance that our statistical findings are real and do not do chance. So that is that. Then choose an appropriate test statistic. Next is test statistic. what I explained earlier, statistic meaning. So in parametric test, we prefer student t-test statistic for testing of mean or proportion, one or two sample comparison of means, and then chi-square test statistics for testing of variance, one or two sample and goodness of it, and f-test statistic for testing the variance, a ratio of two sample or relative variation. Okay, the measurement scale also play an important role in choosing an appropriate test statistic. We might select one set of tests for nominal data and a different set of for ordinal variables. A common ordinal measure used in social and behavioral science research Likert scale. So now then we compute the test statistic. Whatever the sample we have, we have to compute the test statistic, and then we find the critical value of the statistic that are corresponding to the null hypothesis from the table, and then we finally we compare. Okay, then we compare the and then based on the comparison we have a decision whether we have to make a decision on comparison of computed value of test statistics with critical value for critical. Hello, hello,
Yes, sir.
hello.
Yes, sir. Yes, sir.
The power has came now. I am just settling 1 minute. I will take.
Sure, sir.
I think it is fine.
Yeah,
Is
perfect,
it
sir.
fine now?
Perfect. Perfect.
I'm sorry for this disturbance because of this power cutted
Not a
suddenly.
big issue, sir. Please, please.
Yeah. Again, I'm going to share my presentation. Sorry for the inconvenience to all my participants. Okay, so now decision, we have to take the decision. We make a decision based on the comparison of the computed value of test statistic with the critical value. And for one-sided test, we reject null hypothesis if value of the test statistic is greater than the critical value. If we choose a two-tailed test, this alpha is 0.05, we do not reject null hypothesis if z is scored between 1.96 and 1.96, minus 1.96 to 1 plus 1.96. So this is the what, and then we have to make the inference or interpret the results, and then reporting the results. So these are the what are the stages we have to follow as per testing a hypothesis is concerned, which we use testing a hypothesis in both parametric as well as non-parametric methods. So that is very important basic idea about the testing of hypothesis. Okay, now I would like to discuss situation to use non-parametric test. So most important that when we go for non-parameters, so when should you choose with a non-parametric test? Okay, now see this picture. You have plotted data set and found that it is right skewed, better representing the median. Okay, what is the answer of this question? Your area of study is better represented by the median. Okay, and you have a very small sample size in as far as you have very small sample size and non-normal looking data that is not normal. So for that situation we have recommend to use the non-parametric, and you have ordinal data, rank data, and outliers that you cannot remove. That is important point. Typically parametric test can only assess continuous data, and the results can be significantly affected by outliers. Conversely, some non-parametric tests can handle ordinal data, rank data, and not be seriously affected by outliers. So that is the basic differences between the using of these methods. Okay. Now, when do we use parametric procedure? Again, I am question have here to the participants. The following are some situations in which the use of a non-parametric procedure is appropriate. Okay, the hypothesis to be tested does not involve a population parameter. That is important point. Second point, the data have been measured on the scale weaker than the required for a parametric procedure that would otherwise be implied. For example, the data may consist of count data or rank data, thereby precluding the use of some otherwise appropriate parametric procedure. The assumptions necessary for valid use of a parametric procedure are not made. That is also important point. So in many instances, the design of research project may suggest a certain parametric procedure. Examination of the data that I told already earlier presentation, however, may reveal that one or more assumptions underlying the test are grossly violated. In that case, a non-parametric procedure is frequently and only alternative. Okay, so results are needed in hurry and calculation must be done by hand. So that is the advantage of using this non-parametric and the situation when we prefer the using. Now, advantages and disadvantages of non-parametric. What are the advantages? I don't read all those things. I just key point I have to explain here. So that is what the make fewer assumptions, wider scope, and need not involve population parameters. The chance of their being improperly used is small, applicable even when data is measured on a weak measurement scale, and easy to understand. Computational can quickly and easily be performed. These are the advantages. And disadvantages may waste information, difficult to compute by hand for large samples, and tables not widely available. So these are the disadvantages of this method. I must come to the main goal of the today interaction, this lecture, non-parametric tests. So the non-parametric tests are classified into three categories as one sample test, two sample test, k sample test. So you may have a one set of sample, or you may have a two set of sample, or you may have a k sets of samples. Okay, so types of one sample. For the case of one sample test, what are the methods available for one sample? The case, some of the commonly used one sample tests are listed here. What is what? Sign test, Wilcoxon sign rank test, run test, and the fourth one is Kolmogorov mini goodness of it test. So the board why I made, because I have to focus only first three, not fourth, because of the time constraint. And further is about the data assumption. We use median value here. Okay, from a given data set. Median of a set of data is defined as a middle value when data are arranged in order of magnitude. For continuous distributions, we define the median as a point that is what representing mu curl. You can see the notation mu curl, that is called mu curl, for which the probability that a value selected at random from the distribution is less than, and the probability that the value selected at random from the distribution is greater than, that is what mu curl, are both equal to half. Okay, when the population from which the sample has been drawn is symmetric. Any conclusion about the median are applicable to the mean, since in symmetrical distribution the mean and median coincides, as already told. Now first I would like to discuss here what is sign test. In one sample and pair sample sign test. Okay, the procedure for small sample test, what n is given, n is less than or equal to 20. Okay, the sign test is the simplest of the non-parametric test. It is called the sign test because this test is based on signs as plus and minus. The sign test is used as an alternative of the t-test for testing population median instead of population mean. Okay, under the circumstances when the parent population is not normal. Okay, further, It also works if data available in ordinal scale, while the t-test we needed data at least in an interval scale. So that is the differences why we go sign test instead of t-test. What is the assumption of the performing the sign test? The sign test works under the following assumptions. The sample available for analysis is a random sample of independent measurements from a population with an unknown median, that is what mu curl. The variable under study is measured on at least ordinal scale. The variable under study is continuous. Okay, so these are the basic assumptions to perform the sign test. Okay, we must check these conditions are fulfilled or not, okay, before performing the sign test. Okay, so what is the procedure, test procedure? We have a sample. What we have sample form, let x1 x2 up to xn, these are the observations. These samples be an observed random sample of size small n from a population with median mu curl. These observations are arranged in order in which they occur are taken from a parent population having unknown median mu curl, that I call mu curl. Okay, the scientist utilizes only the signs of difference between the observed values xi and the hypothesized median mu naught curl. Okay, so the observed value data are converted into the plus and minus sign. Okay, so whatever observed data we have to convert with respect to the mu naught curl, whatever the differences with the your data with the mu naught curl assumed value, I hypothesized median value, and we have to see whether there is a negative difference or positive difference. Accordingly, we have to convert and assign this sign value. Okay, suppose we wish to test the hypothesis about the specific value mu naught curl of population median mu curl. So we set the null hypothesis and alternative hypothesis as, for one tail test we define the hypothesis S naught, you see mu curl is lesser or equal to mu naught, and versus alternative hypothesis mu curl is greater than mu naught. That is what the right tail test, and the left tail test is what exactly given below. Mu curl is greater than equal to mu naught versus H1, that is alternative hypothesis mu curl is less than mu naught curl, that is what the left tail test. And the for two tail test we have mu H naught is mu curl is equal to mu naught versus or against H1 is mu curl is not equal to mu naught. This is the hypothesis we to define. We must define the hypothesis because our ultimate aim is to verify the assumptions for a population, whether it is true or in false. We have to check. Okay. For testing the null hypothesis against the appropriate alternative hypothesis, we follow the following steps for performing the one sample test. Okay, what are the steps to follow? We convert the given observations into sequence of plus and minus signs. Okay, number one step. Second step, we compare each observation xi with the hypothesized value, that is what mu naught, median value. And then third point, assign plus sign for each sample value greater than or less than mu naught. And then finally, fourth one, when observation xi equal to mu naught, give no information in terms of plus or minus. So we exclude such all observations from the analysis part. Due to such observations, sample size get reduced. Okay, because your hypothetical value, what you assumed, and your observation having the matching value, so that becomes 0, and that's why we have to discard that observations. So because there is not possible of any sign there. Okay, so we then finally your sample size get reduced also, and then we count the number of plus and minus signs. So here yes plus sign is representing number of plus sign, and yes minus representing the number of plus sign. So that we have to count it. Okay, so now finally we expect the number of plus sign successes and number of minus, that is what assumed to be failure signs, are approximately equal. and S plus or S minus follow binomial distribution with parameter NP. Okay, and we assume S plus success is less than the S minus the failure number of failures. Okay, and or there is a possibility, another possibility, number of successes may be smaller than the number of failures. That is also possible. So both possibility we have to see here. Okay, so now another idea about the sign test or paired sample sign test. We assume we have pair of n observations supposed to be x1 y1 x2 y2 and xn yn. We have a pair of observations. In this problem, each pair of sample can be replaced with the plus sign if the first value greater than the second, and minus sign the first value is smaller than the second, or be discarded if the two values are equal. So for each pair, we have to assign the sign based on that plus and minus, based on the first value is less than second value or second value vice versa, and or if it is same the case, we have to discard that pair, particular pair. So decision, now one tells how we have a decision h naught. In this case we expect yes minus that successes is less than the yes plus failure. Therefore, the test statistic yes is the number of minus sign. Okay, the p value is determined, the p value probability that yes is less than or equal to yes minus. If p value is less than or equal to alpha, we reject the null hypothesis at alpha level of significance. Otherwise, we do not reject the null hypothesis. So similarly, for the what is here left tail test, we have to check yes plus that is less than yes minus. Therefore, test statistics the number of plus sign. Okay, so the p value will also similarly we determine, and if the p value is less or equal to alpha, then we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. So this is the decision we take accordingly, the hypothesis setting, and what is the right tail test or left tail test or the two tail test. So this is the two tail test case. The hypothesis is defined. In this case, the test hypothesis yes is the minimum among the plus sign and minus sign. So what is defined? Yes is equal to minimum among the yes plus and yes. Yes, I must tell you, yes plus is the number of plus sign counting. Okay, and yes minus is number of minus sign in your observations. So among them, which one is the minimum? That is what representing by capital S. The appropriateness of the p value we have to find 2 times of the p of the s is less or equal to s plus. S is plus is small, and 2 times of s probability of s is less or equal to s minus if s minus is small. So if the p value is less or equal to alpha, then we reject the null hypothesis at alpha level of significance. Otherwise, we do not reject the null. So these are the strategy we have to follow in taking the decision of the problem we handle. Okay, the procedure for large sample, in case you have a sample more than 20 or 20 or more than 20, the case for large sample case n is greater than or equal to 20, we use normal approximation to binomial distribution. Okay, with mean, what is mean of the binomial case? E of yes is np. Okay, and then n into p's probability is half. We have n by 2. The variance is npq, and np p is 1, q is 1 minus p. That is what npq n by 4. We use normal approximation test. What is what z? Z we define here given in equation 1. That is what s minus n by 2 mean and square root of the variance given in equation 1. When h naught, I must explain here. When h naught is true and n is greater than or equal to 20, z is approximately normal. That is what standard normal, mean 0, variance 1. For large sample approximation, it is common to use continuity correction by replacing s by s plus half in the defining object. Equation 1 then becomes, okay, what is given here. And the actual value of the statistic can be computed by using the above formula and can be compared with the critical value with the standard normal variate table. Now we have to perform some examples how these methods are used in problems, real life problem. The breaking strength in pounds of a random sample of 10 ropes made by manufacturer is given by. The breaking strength is given here for the 10 ropes, and perform scientists to test the manufacturer claim that the average breaking strength of rope is greater than 160 pounds at 5% level of significance. So how to start solution, how to apply the method, scientist. Okay, since the manufacturer claim that average, that is what we assume, I told you we have to take median. Okay, median breaking strength of a rope is greater than 160 pounds. So what we mu call the median is greater than 160. Okay, and its complement part will be mu less than or equal to 160. Hence we take h naught mu less than or equal to 160 because the equality sign is involved there. Equality sign is involved there. Okay, so and the alternative hypothesis is like this. Okay, yeah, yeah. Then yeah, uh, we have to replace observation with sign plus and minus and compare with mu is 160, mu is 160. Okay, so and discard matching observations. Look at the observation, you have observations here, 10 observations here. What I have given in the table? See, I have assigned first these observations, then taking the difference was 160, the median value, the assumed value, and take the difference. So this is 163 with 160 positive, again positive sign assigned, again positive sign is assigned, and here see both the observations are matched. Then we discard this particular 160 observations from the observations. Okay, so 171 obviously is a positive, 150 is less than 160 is negative, 151 is again less than 160. So with that difference we assign the here signs corresponding to the corresponding observations, and then final table after reducing one sample become this. This is the final table of the observations. We count the plus and minus signs. Yes plus is number of plus sign is 7, and yes minus is number of minus sign 2. So in SPSS, what they do, they directly calculate when you input data. Whenever you give the data, they just click it, analyze the data, and go and choose the sign test. Then finally, okay, then result will give. But what is going inside, how the methods is applying there, that is not known to the investigator. That's why it is important to understand how these methods are using in calculating this test statistic. Okay, so this is what we got. Our main role is to find out the S plus and S minus with our given observations. Okay, in compare with the hypothetical value. Okay, so N is what? Number of plus sign and minus sign. So total is 9. So 9 is less than 20 because I told case of small sample and case of large sample. So this is the case of small sample. Since the right tail test we expect this number of yes, number of minus sign is smaller than the number of plus sign. So the test statistic is the number of minus sign. So what is the minus sign? Only 2, as the previous slide I have shown here. So your test statistics finally become 2 because this yes number of minus sign is smaller than we assume the case of right tail test, because it is a right tail test. Okay, we determine p value from binomial table. We have to see when n is 9, p is 0.5, r is 2, this r is 2 here, and then we get the p value is 0.0899. Then what we have a decision? The decision is like this. Since the p value 0.08 greater than 0.05, then we do not reject the null hypothesis. Okay, we reject the alternative hypothesis. We reject the manufacturer claim 5% level of significance. Thus, we conclude that sample provide a sufficient evidence against the claim. So manufacturer claims that the breaking strength of the rope is greater than 160 is not true. So we have checked, we understand how the idea of the scientist is applicable. Okay, once you this scenario understand, then that SPSS is just a moment, just entry data, some ticking idea which test you wanted to perform, and then finally you click, you get the final results. Okay, so that's why the second example is here. Look it here. The following data of IQ is arrested drug abuser who are age 16 years or older. Is there any evidence that the median IQ of drug abusers in the population is greater than 107? Use the level of significance 0.05. So these are the data are recorded here, given in a tabular form. The median IQ of the drug abuser in the population is greater than 107 means we have to take this. So this is your alternative actually. This is the assumption we have to verify in favor of the population. So what this is my assumption. Then we have to see what is the complement. The complement part will obviously less than or equal to 107. So this will be our null hypothesis. So null hypothesis is stated here. Alternative hypothesis is stated. Since mu curl is greater than 107, this becomes right tilde test. So we replaced observation with sign, and sign, that is what, plus and minus. With this comparing with the 107 value. This mu 107. This mu in curl is less or equal to. So we take mu equal to 107. So we compare with each observation and discard when the match observations are matching. Exactly the same problem, similar type of problem. I have taken the differences with plus minus sign assigned in this table, and then finally after discarding this observation we have this, and then number of plus sign and minus sign, and then we get the statistic value, and then finally we have to find the critical value, and then we have to compare. Then finally we come to the conclusion. So this is the working problem, how to apply. And there is another problem which I am showing here. Yeah, I will provide these slides to the participants through our organizer, so you can go through that detail. You can find how it is working. This is the two-tailed test. This is the two-tailed test. Exactly, the hypothesis is setted, and then yes plus yes minus. The two-tailed case, the case we have to see the odd test, that is the minimum between number of plus sign and number of minus sign. So the similar idea is adopted here. The previous two examples, in third example we apply here. Then finally we have, see, look at minimum value. This is the test statistic value one. Okay, so then we have to get the critical value, and then we have to check and compare. For one example is here for large sample approximation test. This is the problem. I must show you the first problem. Yeah, the following data gives the ages in years of a random sample of 20 students from Bishop Senior High School. It is believed that the median age of students in a school is smaller than 22 years. Based on these data, is there sufficient evidence to conclude that the median age of the students from this school is smaller than 22 years? We have to verify this statement. Okay, so for that, we assume that mu cal is the median age. This is the data given. Okay, and we have to verify median age of students from the Bishop's school is smaller than 22 years. So this is what the hypothesis. So this is, and its complementary part will be greater than equal to. So obviously this will be the null hypothesis, and this assumption is the alternative hypothesis, and this is to be verified. This is what the exactly, this is, since mu is less than this value, so it is we call left tail test. So exactly the idea which I have used here. Look at here for this. We compare each observation with this mu 22, and then find which one is positive or negative based on these observations. Serial number 1, 2, 3 up to 10 observations, and look at here. This is assigned here the signs. Okay, with see xi minus 22 I have mentioned here. So what is xi? Xi is these observations, and with the 22. So this we find that we count the number of plus and minus sign here. From this table we got this exactly, and then we have to, since it's the left tail test, we expect x plus is less than s minus, means number of plus sign is smaller than the number of minus sign. The test statistic will be yes, number of plus sign. Okay, so this is the rule. So accordingly, since it is a large observations, larger, since see when s naught is 2, yes, follow this test statistic follow binomial with mean with n is 20, p is 0.5. Since n is greater than equal to 20, we use normal approximation to the binomial distribution with continuity correction. The test statistic becomes. So these all those ideas are implementing directly in the software SPSS, I tell you. So this we have to test statistic, we have to calculate, all these values are given. Then finally we compare with the critical value. The critical value of the Z alpha from standard normal table point at level of significance 5%. This value is minus 1.645. We compare both calculated value and the tabulated value. We reject H naught at the level of significance when calculated is less than Z alpha. So here in this case of the problem, this value is smaller than this value. We reject H naught at 5% level of significance, and we conclude that median age of students of Bishop School is less than 22 years. So I have, based on that, I have given some problems here for the practice to the participants. Okay, so these 5 problems to be worked out from your side and to be reported to the organizer. And then Wilcoxon sign rank test is there. Procedure for large sample. What is the procedure? We have learned from the sign test that utilizes only information whether the difference between each observation and hypothetical median is positive or negative. That is, it considers only signs of differences. This test is useful if the information available, the observation sample is available in ordinal scale only. However, the sign test is preferred when the sampled population is not symmetric. Okay, then yeah, but if the measurement of the observation is available interval or ratio scale, then choice of sign test is recommended, because this test do not take into account the information available in terms of magnitude of the differences. To overcome this drawback of the sign, to test the null hypothesis, there is another procedure that uses the magnitude of differences when these available. The Wilcoxon sign test procedure makes use of additional information to rank the differences between the sample measurements and the hypothesized median. The Wilcoxon sign test uses more information than the sign test, making it more powerful test when the sample population is symmetric. However, Wilcoxon sign rank test takes into account the information of signs as well as magnitude of differences. The Wilcoxon sign test is also used as an alternative of the t-test. Okay, Wilcoxon sign test requires following assumption to perform the method. What are the assumptions? The random sample of size n taken from a population with an unknown median mu curl. The observations are taken independently. The study variable is measured on the continuous scale. The scale of measurement is at least interval, and the sampled population is symmetric. Okay. What is the test procedure? The test procedure is given here. Let x1 as to xn be an observations random sample of size small n from a population with median mu curl. Suppose we wish to test the hypothesis about the specific value of the population median against the corresponding one-sided, two-sided alternatives. So one-sided alternative is, you see, is defined here. Two-sided alternative is also defined. You can see here, and the test statistic steps are followed to find out the test statistic. So we subtract the hypothesized median from each observation and obtain the difference di. Okay, their plus and minus sign as okay. So di is xi minus mu naught for every observations I from 1 to n. If any observation xi is equal to the hypothesized median mu naught curl, eliminate it from the calculations and reduce the sample size accordingly. Okay, if your observations and hypothesized value are same, the case same, we find the absolute value of these di's. Di is the difference of what you have find out with the observations and hypothesized value. So you have to take the absolute value of the observations, mod, or that is we call mathematically modulus of this d1, modulus of d2, modulus of dn for each of the differences. We ranked di obtained in step 3 with respect to their magnitude from smallest to largest. The rank 1 is given to smallest di's and rank 2 is given the second smallest, and so on to the largest DIs. If two or more DIs are tied, assign each tied value the mean of the rank positive of the tied differences. Okay, so now assign the sign to the ranks which the original differences have. Finally, we calculate the sum of positive ranks, sum of negative ranks separately. Under H0, we expect approximately equal to the positive and negative ranks, and also assumption that population under study is symmetry about the median, and we expect the sum of the positive ranks and sum of negative ranks are equal, and the test statistics is depends on just depends on the alternative hypothesis. So the following cases arises. What are the cases arises? I must explain. For the one tail test, as you know how to define hypothesis, I already explained. So in this case, we expect the sum of negative ranks is smaller than the sum of positive ranks. That is what W minus representing the sum of negative ranks and W plus representing the sum of positive ranks. Therefore, the test statistic will be the sum of negative ranks. Decision: if W is less than or equal to W alpha, then we reject the null hypothesis for N, what is sample size, and alpha level of significance. Otherwise, we do not reject the null hypothesis. What is W alpha? W alpha is your critical value. Okay, is obtained from the table. Similarly, we have a left tail test. So for the left tail test, we have to expect that the sum of positive ranks is smaller than the sum of negative ranks. Therefore, the test statistic is the sum of positive ranks. So decision we take accordingly, and then we have to follow the two tail test case, and the two tail case is here. In this case, the test statistic again, like we have to take the minimum among the sum of positive and sum of negative ranks, that what is representing with the W. Decision: if we compare the computed value of the test statistic W is less than or equal to critical value W alpha by 2, and then we reject the null hypothesis for alpha at level alpha by 2 level of significance. Otherwise, we do not reject that. Procedure for large sample approximation: if the sample size having more than 25 or 25, we have the test statistic approximately by normal distribution with mean is given n plus 1 by 4. Variance is given here. We use normal test, that is what Z test for the large sample. That the test statistic Z test is given by, is defined here. This is the transformation. Z is equal to W minus expected value of W by square root of variance of W, and this is again follow a standard normal variate with mean 0 and variance 1. We compare calculated value with the critical value. If computed value of the test statistic is less than or equal to critical value, then we reject the null hypothesis. So this is the procedure what is given. And for the adjustment for ties, we can incorporate the adjustment of ties among non-zero differences in the large sample approximation in the following way. Let T be the number of absolute differences tied for a particular non-zero rank, and then the correction factor is defined here. Correction factor, sum of T cube minus sum of T by 48. Look at this idea is given. Their statistic is, and then adjusted test statistic Z is defined here. Look in the denominator having some changes here with the correction factor here. Then we illustrate how to calculate the correction factor. That is also important. So I have taken some data here, illustrated the calculation of and adjusted for ties in the following data. Look at here. We have observation here. This is the serial number. What we have rank given 1 and 3. Actually, this is rank. This is the modified rank. So these we got two observations are same. We have defined 1, 2. Then what will be the rank for that is called modified rank? Take the average of 1 and 2. This is what 3. Again, I can see here. 1.5, 1.5. This is the average value. So there are two values are ties here, 3 and 3, and the same rank here. The case this T is 2. We calculate T is 2, and then T cube is 8. Okay, what we expecting the above formula. Okay, the correction, that is what they called correction factor. Here, look at here, for 3 observations, 6, 6, 6, 3 times. So we have assigned the rank here 4, 5, 6, and the modified rank is 5, because this take the average of 4, 5, 6 become 5. This is the average. For that case, we have 3 type values. So we count here 3, T is 3, and the TQ is 27. Likewise, we have to work out here for other observations, and then find the sum of this T and sum of TI, TQ. So that is what I have worked here, and that exactly needed in calculating the correction. Now I have to illustrate one example here. A random sample of 15 children of 1 month of older shows the following pulse rate beats per minute. So it is given here observations here for 15 children, and assuming that the distribution of pulse rate is symmetric about its median and continuous, is there evidence to suggest that the median pulse rate of the 1 month or older children is 120 beat per minute at 5% significance? So in this example, I have solution here. In this example, the distribution of pulse rate is not given. So the assumption of normality for t-test is not fulfilled, although all the assumptions of Wilcoxon rank test hold. We want to test the median pulse rate, that is what we define mu curl, of children of 1 month or older is 120 beat per minute. So the claim is to be verified. We have formulated the test hypothesis. So this is what mu curl is 120 versus mu curl is not equal to 120. Okay. So since the test statistic, I must have to, since the test statistic is two-tailed or two-sided, so the test statistic W is the minimum value. We have to the minimum value of this W plus and W minus. So I must show here how this working this data. I have made entry of all this data, this 15 data, and then I have taken the differences. This W, the xi minus this 120. This hypothesized value is 120. And taking this is the tie. Why? Because these two values are same. Then we are taking differences here for all this set of observation which I am presenting. 15 data are there, and then taking absolute. I already told, take the absolute value means the all negative become positive here. So all negative value become positive, and then I have marked here. You see here this 5, 1 is green color, and this one is repeated. So repeated means we have to first we have to assign the rank according smallest to largest observation, 1, 2, 3, 4 like that. So here 1 and 1 having this 1.5, 1.5, and similarly this rate 2 to have 3.5, 3.5, and 5 and 5 have 7.5, 7.5. So this is what the modified rank, that is the average rank, because the two observations are more than 2 observations have the same rank, repetition observations, but the ranks are differs, but we take the average rank, and that average rank is assigned corresponding. That is what the modified rank here. And then we signed rank. What is rank? Positive and negative. One, this is negative 1 is here 1.5. We have to assign the negative 1. So look at here, -2 for negative. We take 3.5. Minus 3. This for this observation this is minus negatives. We take this observation 5. So for this minus 0.6, minus 6, 10.5 we taken here. So we have to segregate these observations with the plus and minus sign here. Of those who are being plus, we have written rank plus and rank minus. This we required actually for calculating the test statistic W, because look at here how I have also here worked out representing how to rank. That I already explained you. Rank we have to give according to smallest to largest, and then take the average. Already explained, but it will be provided to you to make data understanding. I don't go in this table because we have a lot of things, and then from the table we calculated this W plus and W minus. Non-zeros, number of non-zeros is 13 total. Now 15. Now observation become 13. So decision, the test statistic with the minimum 28 is the value, minimum value we take. Then we have to compare this test statistic value with the critical value. Since the calculated value of test statistic and the critical value is up to till we have to see the Wilcoxon sign test table is there. From that table, at n is 13 at 5%, 0.05, we get the corresponding value from the table, that is 18. That is called the critical value. So we compare this value. Since the calculated value is greater than the critical value, we do not reject the null hypothesis. That is, we support the claim, that is aim, the 5% level of significance. Thus, we conclude that the sample fails to provide us sufficient evidence against the claim. So we may assume the median pulse rate of children of 1 month or older 120 beats per minute. Okay, this is one of the example. Similarly, another example I also have attempted. This will be provided. Exactly, I have worked here so that it will be easy to understand. I don't go in the detail because the procedure I already have explained to you. But if you just go through that involved, you can learn how this is. So this is what the two-tailed test. I also have performed one problem for the same data set. So that here, this is here. So how assign the ranks also, all those things I explained here. So you can go through that, that's not an issue. So examples are large sample approximation. So for large sample approximation, this is the example, the data. We have to test the hypothesis. Okay. And since the right tail test, this is the right tail test because this assumptions we have set it according to the problem what is given, this problem. You go through the problem, then you can understand, because similar problem I already explained. So we have to follow the idea what is given there, and the test statistic will be the sum of negative ranks is smaller than the sum of positive ranks. So the test statistic will be the sum of negative ranks. So exactly we follow the idea is there. I have worked out because that we have to show you how this T and T, the correction factor involved in the large sample test case. So these are the problem which I have marked with the color, how to get the repetition, how to get the number of these repetition, this, and then we have to apply this value. We calculate this sum, we find out this sum has founded. Sum of T is 10, sum of TQ is 70, and W plus number of plus sign is 210, and W minus is 23 for large sample case because it's a 21 observations. So then we have to see, this is the formula which already shown earlier, and we using this formula we get the Z value. That is what the calculated value. Then we have to find the critical value, and then we have to compare, and then we take the decision accordingly. So these are, and some problems I have left here for the participant for the exercise, for their practice point of view. Now I come to the one sample test for randomness, that is called run test. Okay, as we are aware about the basic assumption of parametric test is that the observed data is random. Okay, that is a random sample. We further process the testing of hypothesis using an appropriate parametric test based on such assumption. It is always to better check the whether the assumption is true or not. Okay, a very simple tool for checking the assumption is known as run test. Okay, so before discussing the run test, we have to explain what we mean by the run. A run in observations is defined as a sequence of letters or symbols of one kind, immediately preceded and succeeded by letters of other kind or no letters. For example, I will show here. For example, a sequence of two letters, head and tail, given below. See, head, tail, head, tail, like that. This in that sequence is given. So in this sequence, we start with a first letter head and go to the other kind of letter, that is T. In this way, we get first run of two heads. Then we start with this T and go to the other kind of letter, okay, and that is H. Okay, and then we get the run of one T, and so finally we have run of three T's. Okay, look at here, and we see that there are 8 runs. Look at first head, tail, head, again 3 times of this tail, again head, again tail, again head, again tail. So we have 8 runs, total 8 runs. That is what the rand. Because we have to check whether the data is random or not. Randomness we must be verified. Okay. So under the run test, the randomness of observation is judged by number of runs in the observed sequence. Too few runs indicates that there is some clustering or trend, and too large runs indicate there are some kind of repeated or cycles according to some pattern. That is the thing. Okay. For example, the following sequences heads, tails is obtained when tossing coin 20 times. Look at here. So this is what. In this sequence, what we find, we have 2 runs. Okay, a run of 10 heads followed by a run of 10 tails. Since similar items tend to cluster, okay, together, therefore such a sequence could not be considered random, even though as would theoretically be expected 10 heads and 10 tails out of 20 tosses. Okay, so in another example you can see here, suppose the following sequence of heads have been obtained. You look at here, 1 to 20, head tail like this. Okay, like this. So in this sequence there are 20 runs, because as I shown 10 and 20 runs, 10 runs of one head and each, and 10 runs of one tail each. This sequence could not be considered random because too many runs indicates a pattern. So that is not, that we not consider the random. Okay. So on other hand, if sequence of heads and tails thoroughly mixed, such as 1 to 11, look at all those combinations where neither the number of runs too small nor too large. Okay, this type of sequence may be considered random. Therefore, in testing for randomness, ordering or positioning of the items in the sequence is essential, not the frequency of the items of each type. Okay, randomness for a test for randomness is of major importance because the assumption of randomness underlines statistical inference. In addition, tests for randomness are important for time series analysis. The test runs procedure is used to examine whether or not a sequence of sample values is random. Okay, let us discuss some more examples for a following sequence of uh, sample values. Okay, yeah, look at this 21, 22, 24, 27, 30 like this. Each observation is denoted by plus sign if more than the previous observations, and minus sign if less than the previous observations as shown in the table. Look at here. So first you see 21 is less than 23, likewise 23 is less than 24, 24 is less than 27, 27 less than 20, 30th. Next one you look at 28 is greater than 27, 27 is greater than 26, like this. So accordingly 1 and 2 is given here. Okay, now I do explain. A run is a sequence of signs of the same kind bounded by signs of other kind. In this case, we doubt the sequence is randomness since there are only 2 runs. Okay, if there is another order of occurrences of observations like this, what is given, you see exactly given in this table 25, 22, 27 like this. Look at the previous value is smaller than the next value, this one, and the 27 plus 23 minus, like this. So what is given here, we would doubt the sequences randomness because there are too many runs, 10 in this instance. Okay, too few runs indicate that sequence is not random, has persistency, whilst too many runs also indicate that sequence is not random, is a zigzag. Let us now consider one sample run test. This procedure helps to decide whether the sequence of sample values is the result of random process. Okay, assumption. Run test makes the following assumption. Number one, the observed data available for analysis consists of a sequence of sample values recorded in the order of their occurrence. The observed data should be such that we can categorize the observation into two mutually exclusive types. The variables under study is continuous. Let x1 has to up to xn, and these observations are given. These observations are given here. Okay. In order in which they occur, generally we interested to test whether the population or a sample of sequences is random or not. So we consider only two-tailed case. So sequence of samples values is random. The sequences of sample values is not random. That is what two-tailed. Okay. So we discuss general procedure. General procedure is given here. We start verifying the data, the symbolically form such a sequence head or tail A, B, etc. on the numeric form. So accordingly, we have to calculate here median of the given observations. The formula and conditions are given here. I don't take much time because we have other ideas, and then we have followed by this some presentation of SPSS data. There are some these steps to follow, and then finally take the decision. Here, tide, in the case of tide values, we have here some formula, and for large sample approximation, exactly we have to follow the previous discussion I have worked. Example you see here, count the number of runs and test whether the heads and tails occur in random order. So that is what. For counting the number of runs, we start with the first letter, a head, H, and go up to the other kind of letter, that is T. In this way, we first run is 1H and get counted. Further runs in a sequence of observations. In this way, finally, we observe the total number of runs is 11 as shown below. You see. We want to test the randomness of the sequence, and we go for run one sample test. Okay, we want to test that the given sequence head and tail is in a random order. So we claim our given sequence head and tail is a random order, and complementary part is not in random order. So hypothesis is stated here. Look at the hypothesis, and number of times head comes 8, and number of tail T comes occur 8 times also. The R is what? Total number of runs in a given sequence. So for run test, the test statistic is total number of runs is given in sequence is what? N1 is 8, which is less than 20, N2 is less than 20. So the small sample case is here. So lower and upper critical value of run corresponding to N1 8 and N2 8 at 5% level of significance we can obtain from the table. That is what? RL is 4, RU is 14. Since the observed number of runs is 11, which lies between 4 and 14, so we do not reject the null hypothesis. We support the claim 5% of significance. Thus, we conclude that the given sequence of head and tail in random order. So, likewise, some idea I have given. You can check, you can verify, you can work. Some examples also I have worked out here. You can go through that. I don't want to take much time, and some problems for exercise. Okay, so this is what I discussed about the one sample of this based on this non-parametric. Now I will go to another presentation, another slide, and that I will here stop sharing just a moment. I have
Participants, you can fill up the attendance given in the link. It's in chat box.
Yeah, that is what the non-parametric two sample test, that is what the pair T test, Wilcoxon pair rank sign test, and Mann-Whitney test. So in my last presentation, we have discussed about the basic differences between the parametric non-parametric test, the concept of data associated type of data with examples are presented. Some highlights of testing hypothesis are given. Further, some idea of checking of the normality of the data are described. Some well-known methods for non-parametric one-sample tests are elaborated with number of examples. In this second part of my presentation, I will focus on the different methods of non-parametric sample test. There is an investigation of the characteristics of the two population, or comparison of the characteristics in two population, which is required to identify the best one. Such study are performed under the parametric setup when the distribution of the population is known. Besides, when these assumptions of the test is not fulfilled, as distribution of the two populations are not known, what we'll do in such situation, such problems are going to address in the second part of this lecture. What is there? That is what we will describe how to perform the interpret the paired sign test, and Wilcoxon match pair sign test and Mann-Whitney here. So here in this problem, this is what in real life situation, humanities, sciences or social sciences, marketing and management sciences, we observe two related groups of pairs, and we are interested to examine differences among two related groups. This often happens when the observations are recorded as before and after. Here, the paired observations are recorded on the same individual or items. In this situation, we use paired t-test. If the assumption of paired t-test is not fulfilled, then we use signed paired test. Okay, that means paired sign test is a non-parametric version of the paired t-test. Okay, so I will go here for the what is the assumption here. The pair measured are independent. Measurement scale is at least ordinal within each pair. Okay, so this is what test procedure I must have to explain you. Yeah, so this is what the observations with the pair of random observation of n independent units and items individual. This pair of observation recorded as before and after. Okay, and then our test is to whether there are in effect of diet, training, treatment, medicine before and after, etc. We frame the test hypothesis. So what is the how to test the hypothesis frame? For two tail test, this is the what mu mu1 curl is equal to mu2 curl for these two population is same, and difference is 0, versus alternative hypothesis is not equal to mu2. One sided test, right tail test and left tail test. I already explained how to formulate the hypothesis, and then I come to the steps. We take the first step, we take the difference. Okay, so look it, we find the difference xi and yi, two set of observations you have, paired of observations, and only sign differences is plus and minus. So we have to, if xi minus xi and y have a positive sign, and then we have to replace with the pair of observation with the plus sign. If negative differences, then we have to assign the negative sign. Okay, and then when these are same, then that particular observation to be discarded. Okay, we count the number of plus sign and minus sign, and in that when we null hypothesis to the population distributed on the basis of the sign of the difference, we have expect the number of plus sign and number of minus signs are approximately equal. Assume that the number of plus sign and number of minus sign follow binomial distribution, exactly the procedure. And one tail test, this is the idea. I will come to the problem better. The idea is exactly what I explained earlier cases. Okay, because we have the time constraint. Yeah, see this example. This is the pair observation. We are going to perform the sign pair sign test. So for these observations in this problem, the rating is given the pair form. Okay, so it can be considered as the case of dependent samples, but assumption of normality is not given. Also given data is the form of ranks, so we cannot use the paired t-test. Okay, so that we go for the paired sign test. Okay, we wish to test the product of A and B are equally soft. mu1 curl, mu2 curl are the average rank of softness of the product A and B respectively. So that is the hypothesis. We frame the hypothesis is given here. You can see here in the slide, and the test statistic is minimum among the number of plus sign and number of minus sign. So that is what exactly the similar type of the idea which I already explained. That's nothing new here. So we see this is the product A, product B, and then they're taking the difference. We have the rank, the observations, and the number of non-zero observation is 10 here, because there is no equal observation, the observations and hypothesized value, and the number of plus sign, number of minus sign, take the minimum of this exactly. And then we find the critical value from the table, and then we have, this is the critical value here, 0.3438, and then we compare the p value with the at a 1% level of significance. So this value, what you have, the p value is greater than this, so we do not reject the h naught and support the claim, thus conclude that a sample falls to provide sufficient evidence against the claim. And so we may assume the product A and B are equally solved. Like that, this is the scenario and strategy we discussed. The similar type of examples before and after observations are recorded, and I have worked out all these examples in detail. You can follow. I think there will not be problem, and some problems for the exercise. Now the Wilcoxon match paired sign rank test is here. We have previously discussed about the perform the sign rank test and test for one sample test. We the Wilcoxon sign rank test also useful in comparing the two population for which the pair observation, it is known as Wilcoxon match pair sign rank test. Okay, as such, the test is good alternative to the pair t-test in case where the difference between the pair observations are not believed to be normally distributed. Okay, and then pair sign test discussed here. Yeah, pair sign discussed in previous section and is also useful for the same situation. The pair sign test uses only the information whether x is larger or smaller than y. That this test is fine if information about the observation sample is available in ordinal scale only. But if the measurement of the test, just a minute. Observation is available interval or ratio scale, then choice of paired sign test is not recommended because this test do not take into account the information available in terms of the magnitude of the difference. To overcome to drawback, the paired sign test Wilcoxon match pair sign rank test do the job for us, which takes into account the information signs as well as magnitude of differences. The Wilcoxon match pair sign rank test is exactly the same Wilcoxon sign rank test described in the one sample test. So one sample test here, we have performed deviation from each observation with median value. That is what given here. Wi is equal to mu I minus xi minus mu naught call. But in two sample case, we have to take this difference xi minus yi. So what is the assumptions? Assumptions is also given here. You can find here assumptions is here, and then I come to the problems. So we have a pair of observations of yum independent units, items, individuals, each with the two measurement as before and after training, diet, treatment, medicine, etc. As given, two median for the population before and after. Our interest is to test the hypothesis diet, effect of diet, training, treatment, medicine after and before. We have to see here hypothesis. I don't explain, we already have explained this, but these are the steps. I will come to the directly some problem, and then I will demo the SPSS part also for large sample case exactly. So this is the problem. You see child number, look at 1 to 12 and before, recall before and after. Okay, we have to check here. So as per this statement, hypothesis is formulated here. Hypothesis is formulated. I have explained here. And here in this case, you see, we have taken the first observation set of observations, second y, before, after, and then taking the difference, that is what representing w, x minus y. And this is type, and because these two observations are same, and then after that taking the absolute value, all negative become here positive. And then I have marked with the color which one has repetition, the observations. And then we have taken sign, and that is what negative one is here taken, positive one what we have assigned here all negative because it has a observation with the negative rank. And you see here the difference is actually here. and rank is here given. And then we have count the number of plus and minus, that exactly here what I have shown here in the picture and the table. The sum of positive rank, sum of non-zero rank now become 9, because there are 3 values are the same. Therefore our observations reduced to 9, 12 to 9. Okay, now so that the value of test statistic W plus is 2. Here only 2 W plus is there. The critical value, the table value test statistics for one tail test corresponding to n is equal to 9 at 5% significance is 9. Since the calculated value of test statistic is here less than the critical value 9, we reject null hypothesis, support the alternative hypothesis. Like that we perform this test. Okay, and similarly I have worked out this another examples for your better understanding. And this I have blank because you have to work and find in the previous example similar to this is for the large sample case. This is for the large sample case. The methodology is already explained there. I don't go again because I have to, we got shortage of time here. And some more examples I have worked out here for your better understanding these problems. And then these are some problems for the exercise. So you can go and do exercise of this yourself. Now come to the Mann-Whitney U-test. In the in the previous section, we discussed the concept of paired t-test and Wilcoxon sign rank test. These methods are applicable when the observations are dependent or paired of observations are collected on a subject at 2 different occasions or 2 different time points, or different treatments or drugs are administered. Opinions are recorded at 2 different time points or 2 samples of population. So these are the circumstances which I could explain here. Whenever researchers are interested to perform the testing of differences in means of 2 independent population, then we use the 2 sample t-test. To use the t-test, however, it is necessary to make the set of assumption. In particular, it is necessary to 2 independent samples be randomly drawn from normal population having equal variances, and the data be measured in at least in the interval scale. Okay, so but most of the time it is seen that customer behavior, marketing research, experiment of psychology, etc., generally the data are collected in ordinal scale and the form the population is not known, and the form of the population is not known. It is impossible to perform the parametric t-test in such situation. Hence an appropriate non-parametric technique is needed. In such circumstances, a very simple non-parametric test is known as Mann-Whitney U test may be used. So test, some detail is about the test. This is the assumption about the test. The procedure, we have set first observation X and Y, 2 independent random samples from 2 different populations with corresponding medians are given, and test is setted here left tail, right tail, and 2 tail. And this hypothesis can be defined in the distribution form also, which I have given here, and then the steps are given here. Rather than I have to show some problems better, so that it will be easy to understand. For large sample case, I also have discussed here. Yeah, this is the one problem I want to discuss with you. Okay. Yeah. So this is the what given the problem, and data is given. Okay, medium of instruction. Okay, so look at rank. This is a rank given, and whether evidence or difference of performance based on 2 methods. Okay, so this is the case of 2 independent population, and the assumption of normality of both population is not given. Also, the given data are in the form of ranks, so we cannot use the 2 sample t-test in this case. Also, sample sizes are small. We cannot use Z test also. So for Z test, we need to have large sample. Therefore, we go for Mann-Whitney U test. In this example, our interest is to test the performance of students based on 2 methods is different. If me1 curl, me2 curl represent the average median ranks of students who taught by traditional and experimental method respectively, our claim is to verify this. This is the hypothesis. Exactly the frame, how to frame the hypothesis, and then combine what is mentioned here. I have mentioned here. The combined ranks are given. Also, n1 is equal to n2. Both observations are equal actually. equal number of observation in both. So we take any sum of the ranks, first sample or second sample, because both our samples have the same size. Okay, so we can take any one. We consider first sample. So the first sample ranks are added as 83. Okay, so we use this test strategy U S minus this, and this we S is this is the total 83, N1 is 10, and we got the test statistic. So since two tests, so lower and upper critical value of the test statistics for two tests corresponding to N1, N2. N1 is 10, N2 is 10. At 5% level significance is given. You can get from the tabulated value, and the since calculated value test statistic 28 is less than the critical value 79 and 131. We reject the null hypothesis and support the alternative hypothesis. I think you follow the idea. What I want to convey, the different methods of this with these examples are also given here. Now I think there is a very less time. I have to some examples have to work out through this SPSS. Okay, so now I will stop this. Now I will just a moment. Yeah, I think you can see this SPSS. Okay, so first of all, what to do here, I must just a moment. Yeah, first of all, what we do here, we have to define your variable. How to define define your variable? First, you click this variable view. Okay, when you click this variable view, we have to define the variable view. How to define? I must tell you that what is the here. See, last underscore variable, and then enter, and then again I have to define here what is called the supposed to be this year, last year and this year, these two set value this year. So here last year supposed to be, and this is here this year. Okay, after that again come back to our view data. So in view data, we have to enter the type the data. Okay, what we have data supposed to be, I have to type the data here. Just a moment. 31 14, okay, 53 18, and 21 44 12 and 36 22, and then finally 29. This is the last year observations. Then we go enter the this year observations here, exactly 31, and then 14 50 14 50, okay, and then 30 28, just a minute, 48 48 35, and then 32 32 23 30 34. So the data we have entered. After that, we have to analyze your data. Okay, for the analysis, we have to go analyze. Okay, okay, we have to go to analyze. Analyze is here. Then we have here what? Non-parametric test. And then we have go two related samples, last year and present year. Then we have to what? Then we have to click this, because you see test pairs, the first pair, first variable, we have to click here. It came. Then for the next one, we again click here, the second variable. And our aim is, our wish is to perform Wilcoxon sign rank test and sign test. So we have to click here what test you wish to perform. Okay, then we have to make it okay. See, this is the final output of the our data set. And look at exactly what is there. I have also made in and discussion about the result. I would like to discuss here. Just a moment, I will stop sharing here. And just a moment, I have to here. Yes, yeah, look it, we have analyzed data, and what output comes, I will like to explain here. See what we have performed. See, this is the Wilcoxon sign rank test is there. So this is the output came, what I have tabulated here exactly, SPSS output. And this is the test statistics. What interpretation of this? So from the above SPSS output resulting reporting the results from the Wilcoxon sign rank test, the first output table called ranks provide the Wilcoxon W, obtain value from the sum of ranks column. We select a smaller of the two values. Okay, so this is what 5.5 among these two, sum of this rank plus and minus. So this is the minimum value. You can see output here. Output you can see here. Here, see here. Negative ranks, sum of ranks 5.50. Positive ranks 30.50 exactly. So among them, which one is minimum? We have to take this value. This is what 5.5. Our test statistic is this. The computed output table test statistics returns the critical Z score value. And what is Z value? The what is called the SPSS calculates the two-tailed significance p value is 0.81. You can see the second table what I have showing there, this 0.81. So we got this exactly. So easy to perform this using SPSS exactly. Then we have what? Look at here. Based on the result SPSS, the number of successful interventions was significantly different. W 7.5, N is this, P is this. Actually, this is 5.5. I'm sorry, this is 5.5. So and W plus is 30.50. The was larger than the sum of the negative ranks. The negative ranks is 5.50, demonstrating the positive impact of the program. And what about sign test? This is the sign test. Exactly this value came. What I have taken copy from there. And from the report and results, the first output table called frequencies, the first one, and provide the negative differences, positive differences, ties, total comparisons. You can see here. See, negative differences, positive differences, ties, and total. This output is here. Okay. So how do you interpret? A second was is test statistic table. You can see here, and the value is given 0.89289. This is a two-tailed test. So look at here. The second output table test statistic returns the two-tailed significance 0.289. Based on the results, the sign test using SPSS, the number of successful interventions was not significantly P is because this value is greater than 0.05. Okay, so this is what the how do you interpret the outputs? That's most important. Okay, so yeah. Yeah, so hello, hello
Yes, sir.
sir, shall I go for the next presentation? Hello.
You can take 5 minutes more.
Okay, then I do explain. No, just a moment. So one sample, two sample, this is the case sample. I suggest you to exactly work out for other problem which I have worked out by hand also. Okay, so this is what I want to present you. Just a moment, I have to make it little bigger. Yeah, so this is what non-parametric case sample test. I just want to demonstrate this idea. Pascal-Wallis test, Friedman test. So we initially started concept of non-parametric test for one sample, two sample. So we have discussed one sample non-parametric test for testing the hypothesis. These are the what I discussed earlier. I have mentioned here. Okay. So in such situation, we generally use analysis of variance technique. But ANOVA, I must tell you, there are some possibility where three or more populations are under study. Earlier we had two samples from the two different populations. Okay, now there is more than two populations. The case what we have to work, which test is appropriately used, that is most important. So for that we are interested to test the equality of their means and our medians, because we have more than two populations or more than three populations. Then in such situation generally we use analysis variance. You might have been aware, but ANOVA test procedure require assumption of the population being compared are all normally distributed with equal variances. When population under study are non-normally distributed, then we cannot recommend the using ANOVA procedure. Therefore, we require non-parametric test, and that not based on any assumption about the shape or form of the population distribution. Such circumstances, we recommend Pascal-Wallis and Friedman test. So when we have more than two population or three or four or k population intend to comparison, basically we want to compare these population. Okay, so under the study are not normally distributed, we cannot use the ANOVA procedure, I already told. Therefore we require non-parametric test, not based on any assumption about the shape of the population distribution. We recommend here Pascal-Wallis test here. What is the Pascal-Wallis test? These are the assumptions. Case samples are randomly and independently drawn from their respective population. The variable under study is continuous. The measurement scale is at least ordinal. The population are identical in shape that expect for the possible differences in location. These are the assumptions. Look at these observations. Observations having from the we have the K population. First set of observations from the first population N1 observations. Second set of observation is there for the second population. Likewise, K population, we have Kth population. And sample number first two up to K. So this is the structure of the population, and the samples from the K different populations are randomly drawn. That is the important point here. We are interested to test whether the K population having the same median or not. So this is our interest of this study here, to test how to set the hypothesis. All K population have the same median. All K population have not the same median. This is alternative. So likewise, we have to set. I recall that in ANOVA generally we test the effect of treatments, and like it's not all the K treatments have the same effect, have not the same effect, like where null hypothesis, alternative hypothesis are set here. Then the steps are given here, how to rank, and the steps to find out the test statistic. The test statistic, this is defined here, KW, Pascal-Wallis. This is the test statistic. We require the rank value here. Ri is the rank, depending for the ith set, and Ni is the number of observations for ith set. So this sum we require for all the K samples, all K samples. And then in case if ties arises, the case we have to use the adjustment factor, we to find adjustment factor, this C we require. And then finally the test statistic, that is called KW adjusted, that this is KW by C, this ratio we take, then we get the observation that is called test statistic, and then we compare with the table value from the given table. So this is the problem. One problem is there, you can see there are 3 feet and weight gains, median weight gain due to 3 feet are same by Pascal-Wallis test at 5% level significance. So I have defined the test statistic. The test statistics are observed using this statistic. So see, ranks are given corresponding for all these 3, for first sample, second sample, and third sample. Okay, so this is what R1 is calculated for the first set, first feed, first set of sample, second set of sample, we have the second rank, likewise third rank. R1, R2, R3 are calculated. And accordingly, we have to calculate the test statistic is calculated, and decision is with the critical value we have to find out from the table, and that with the k is 3 set of sample, three sample, n1, n2, n3 are given corresponding sample, and this is the value, the critical value. Then we compare with this value with the calculated value and critical value, and then we have to take decision whether this value is greater than the critical value, then we reject the null hypothesis, and then we have to make our conclusion accordingly. And these are the some examples, working examples are also here. So I think without taking much more time, I will provide these slides to the organizer. They may give to the participants to better understanding. Okay, sir. Thank you, sir. Thank you very much for the opportunity. I welcome any questions or queries from the participant side.
So if any query is there, please you can unmute yourself and ask sir directly. Any queries? You can also put your questions in chat box. I think there is no more questions, sir.
Acha.
It was a great session, sir, from your end, sir, regarding explaining all the non-parametric statistics and tests, and explaining side by side with different examples. It was a great learning session for all the participants, I hope. Thank you, sir.
Thank you.
I request Pragnaditya Das to please give the vote of thanks quickly to sir.
Yes, sir. Good afternoon to all. I am Prabhaditya Das, research scholar from Department of Business Administration, Assam University. First of all, I am thankful to Dr. Deepjyoti sir for providing me this opportunity to propose vote of thanks. On behalf of all the participants, I take immense pleasure to express my heartfelt gratitude to the resource person, Dr. Navin Chandra sir, Associate Professor, Pondicherry University. Sir has presented the non-parametric one sample, two sample, and k sample test in a very lucid manner and imparted a wonderful theoretical as well as demonstration for problem solving using SPSS. Belonging to research fraternity, I believe that this session will be of great helpful to us. We are really enlightened, sir, with your valuable knowledge and presence. Thank you so much, sir, for sparing precious time from your busy schedule. Thank you once again.
Thank you, Pragnaditya, for your vote of thanks.
Welcome,
and thank you, sir, for joining with us in this FDP. I hope that we can engage you in future too in similar occasions.
Thank you, sir. Thank you. Thank you, sir. Thank you, sir. Thank you.
So here we are coming to the end of this session. So we'll be meeting you again at 12:15 p.m. So let us have a 5 minutes break. Thank you.